Hi guys, and welcome to today's video on, well, the Northern Hemisphere solutions for the Further Maths Paper 1 core modules. That is a bit of a mouthful. My name's Darren, Maths Guru, really good to see you. Now what I'm going to do is go through each of the answers for the core module. So that's going to be the data analysis and the financial section, and I'm not going to just give you the answers, I'm going to tell you why the answers are the answers, all right? I know, random, huh? All of this, learning and videos and what have you, help you with your trial exams, your real exams, and there are videos online at mathsguru.com, totally free to sign up for you to have a look at. Otherwise, I think I'm good to start. Okay, so question by question, here we go. Data analysis, question number 1. The histogram box plot below shown below both display the distribution of the weight or the birth weight in grams of 200 babies. Thank you very much. Question number 1, the shape of the distribution. So the minute I think about shape, I'm thinking about positive skew, negative skew, or symmetrical. So the shape of the distribution of the baby's birth weight is best described as positively skewed with no outliers. Rubbish, there are absolutely outliers. So fingers crossed every one of you knows that those dots there mean there are outliers. So anything that says no outliers cannot be true. Right? Because there are definitely outliers there. There's also one here. So that gives an answer between 2. Now, generally with multiple choice questions, you can discount 3 straight away, all right? Or should be able to, with your knowledge, discount 3. Then it comes down to the 2. Positively skewed with outliers or approximately symmetrical. Well, as far as I'm concerned, this box plot here seems to suggest that the median is somewhere in the middle. It's not too far to one side. You can also see here that it seems to be relatively symmetrical. So I'm not going to say positive skew, I'm going to say approximately symmetric with outliers. And believe it or not, that is the correct answer. And when I say that's the correct answer, I mean by VCAA. So I'm checking the answers here as we go through to make sure that nothing goes wrong. The number of babies with a birth weight between 3,000 grams and 3,500 grams is. All right, so the first thing is 3,000 and 3,500. So we're looking at this bar here, which means I need to look and read off. Now, it's not 30, it's 30%. So what it's saying is that 30% of the babies are between 3,000 and 3,500. So how many babies were there? It told us there were 200 babies. All right, so 200 babies, so we want roughly 35% of 200. So firing up my calculator, what are we going to do? We're going to do 35. We're going to divide that by 100, and I'm going to times that by 200, which gives me roughly 17. Obviously, the answer here says is closest to. 74 seems to be closest to 70. Always look for that closest to, and D gives me my correct answer. The total birth weight of a sample of 12 babies is 39 kilos. The mean birth weight of these babies in kilos is, so that's the total birth weight. So when you work out the mean, which is X bar, you take your total, which is 39, and you divide it by the number of. So again, we're going to do 39 divided by 12, hit Control Enter, and we get 3.25, which gives me D as my correct answer. It's weird really, because that question seems overly simple. Question number 4, the box plot and dot plot shown below both display the distribution of the gestation period in weeks for 117 baby girls. All right, here we go, 117 baby girls. All right, let's have a look at zooming so we can see the whole question. All right, the median gestation weight is, right, so if we want the median, we're going to take the number of data items, which they've told me is 117. I'm going to add 1 to that, 117 plus 1. And I'm going to divide it by 2. So 118 divided by 2. I'm just going to do that on my calculator because I'm not wasting time with making silly mistakes. Is 59. So I want the 59th baby. Okay, so by zooming in, I need to count the babies. And the good news is, when you zoom in enough, you can tell that each of these spaces here counts for 5 babies. So we were looking for the 59th baby. All right, okay, so we've got 1, 2, 3, 4, 5, 6. All right, so there are 6 up until there. I've got how many here? 5, 6 babies there. I'm just going to add these up individually now. I've got 3, I've got 5, 10, I've got 15 there. So if we add those together, we've got 6, 12, 13, 14, 15. So up until here, we now have 30 babies. Here we've got 5, 10, 15, 20, 25, 26, 27, 28 babies. So that makes up till there was the 58th baby. And so the 59th baby is going to fall into 40. So let's zoom back out. So question number 4, I think, is 40. and that was in fact the correct answer. So again, the trick there was they didn't actually give you any of these measurements there. You had to go and look and say, well, okay, what does each of those stand for by counting the dots. And question number 5, the birth weight. Right, so basically this information is going to relate to questions 5 to 7. A baby selected at random from this population has a standardized weight of Z score. Whenever they give me the Z score, I always write down Z is equal to X minus mu on sigma, right? Where mu is the mean and sigma is my standard deviation. Which of the following calculations will give the actual birth weight of the baby, right? So when we want the actual birth weight, we're looking for the value of X. They've given me Z as minus 0.75 is equal to X. We're trying to find mu is the mean, 3300, and the standard deviation is 550. So what am I going to do? I'm going to now multiply both sides by 550, minus 0.75 times 550 is equal to X minus 3300. And to get the value of X, I'm going to do 3300 minus 0.75 times 550. Now let's see whether actually that matches any of my answers. And as it turns out, it seems to match B. And so for question, or does it match B? No, got tricked, got owned. No, it didn't. So basically, let's just check and make sure it matches C. So C is my correct answer. And again, always make sure you check the other multiple choice questions. Oh, I got owned on that. Using the 68, 95, 99.7 rule, the percentage of babies with a birth weight of less than 1,650 grams is going to be closest to. All right, again, I got tricked on this question or a previous question in a different exam because my diagram just simply wasn't big enough. So we know that's 3300, and I'm going to keep adding on 550 or taking away 550. Right, so 3300 minus 550. And what are we going to get there? 27. So that's going to be 2750. I'm going to take away 550, and that's going to give me 2,200. So my next one is 2,200, and my next one is going to be 1,650. All right, so what it says is the percentage of babies with a birth weight of less than 1,650 grams. That's going to be this section here, which basically is, so if we remember, we've got 99.7%. I take that away from 100, which gives me 0.3%, and that's both ends. When I divide by 2, it gives me 0.15%. Now again, I work this out because I can. You should have this in your summary book with all the diagrams to show you what each of them is. So 0.15 would give B as the correct answer. A sample of 600 babies was drawn at random from the population. They've given me a number again. I'm guaranteeing I'm going to use my percentages. Using that rule, the number of these babies with a birth weight between 2,200 and 3,850. All right, so what have we got? 3,300. I'm going to add on to that 550, which should give me 3,850. So adding that on there, I want 3,850. So because it wants between 2,200 and 3,850, what do we need? Right, well, the first thing is I know that because it's called the 68, there is 68% of my data there. So because I know the next one's 95, what I tend to do is 95 minus the 68 I've already got, gives me 27, divide by 2, gives me, he says, stupid answer, calculator, 13.5%. So again, I know that's 13.5%. You will use your diagram. Please make sure you have this in your thing. So now what I'm going to do is 68 plus 13.5, that is my total percentage. So I have 81.5% of 600 babies. How are we going to do that then? We're going to divide that by 100. I'm going to multiply by 600, and that's going to give me approximately 489 babies. So question 7E was the correct answer. Question 6, the variables recovery time after exercise in minutes. Oh, I know that's numerical. I'm already, see, I've done so many of these past papers now. I'm almost knowing what I'm looking for, and that's the advantage with Further Maths. The more past papers you do, the better you're going to get. And the fitness level below average, average, and above average, they are, so that's categorical. All right, so this one here is categorical, and it is ordinal because it has some sort of order. This is going to be numerical, and because it's time, it's going to be continuous. So let's now see what it's asking. They are both numerical? No. They're both categorical? No. An ordinal variable and a nominal variable respectively. Well, and again, ordinal and nominal both mean categorical. So notice there we've got three of them completely gone. A numerical variable, yes, and a nominal variable, nope. So hopefully the last one says a numerical variable and an ordinal variable. Oh my goodness. So that would give question 8E as the correct answer. Okay, in this question, we're given that a slope has a line of y plus equals a plus bx is fitted to a set of bivariate data. The set of the bivariate data, yada, yada, yada. The slope of the least squares line is given to, and again, these are formulas that they put in all the time. It's one of those ones that are sort of covered in the book, and then we move on. But the one we're going to need, I'm just going to check this, is that the value of a is given by y bar minus b times x bar. They've given me the value of a. They've given me the value of y bar, and they've given me the value of x bar. Right, let's see what we got there. So we've got 3.1 is equal to y bar 5.60 minus the value of b, which we're trying to find, multiplied by 5.50. Okay, so knowing that it's got 5.50, there's a number of ways of doing this. What can we do? Let's just use the solve function on my calculator. Right, so solve 3.1 equals 5.6 minus, let's call it x, times 5.50, and we're going to comma exit to say solve for x, and out comes a value of 0.45454545454545, and so it wants it closest to, so question number 9, the answer is B. A student uses the data in the table below to construct the scatter plot shown below. Okie dokie. A squared transform is applied to linearize the value of x, so we're going to do an x squared against y. A least squares line, the equation of the least squares line is closest to. Okay, so what we're going to do, fire up my calculator, and I'm going to do control, insert, let's do a list and spreadsheet. What have we got here? I've got my x value, I've got my y value, and I want to do an x squared value. I just call it x squared. Now, obviously, I'm going to put my data in, 0, 1, 2, 3, 4, 5, 6. So having put in all of my data, I'm going to put the equals there and say, well, we actually want that to do x squared. Hit enter. It wants, am I a column reference or am I a variable reference? We want variable reference in this case. And we'll notice we got all my x values squared. And the good news is always check, or the point here is just check that they're right. I'm now going to do control and insert. If you're using the Casio ClassPad, you have your own ways of doing this, but I'm at a school now that uses the TI Inspire again. Data and statistics, right? You'll notice it says click to add a variable. Well, we're trying to do an x squared against y. So we're going to do add x squared, add y, and ka-ching. There we go. That seems to have linearized that data. Yes, no, maybe. And so what we can do now is go menu, analyze, regression, and let's show least squares regression line there. So it gives me something along the lines of y equals 98.43, so we're going to y is equal to 98.44. What is it? Minus 1.59, and it's not x. Again, your calculator will trick you, and the exam board want you to be tricked because it's not x. Remember, we actually had an x squared. It just doesn't know that. So what are we looking for? 98.44. And because the question wants the one that's closest to, well, the one that seems to be closest to actually is the one that has this minus 1.59. That's 1.57. So question number 10, B, was the correct answer. And obviously for a moment there I got tricked because I was like, it's not exact, but it does say closest to. Question number 11, the Human Development Index and the mean number of children per woman for 13 countries is related. The relationship is non-linear. To linearize the data, we're going to use a log 10 transformation. Okay, log 10 transformation is applied to response variable children. A least squares line is then fitted to the data. The equation of the least squares line is given by that. Using this equation, the mean number of children per woman for a country with a HDI of 95. These are pretty standard questions. They want you to substitute and then undo the log 10. And you can use your calculator in two ways here. I'm going to do it by hand first. So I have log 10 of children is given 1.06 minus 0.00674 times the HDI, and they've given me a HDI of 95. So if I put that into my calculator and work out what's on the left, let's go back to my main screen here, 1.06 minus 0.00674 times 95. So that gives me 0.4197. To get rid of that log 10, what I do is raise that number to the power of 10. All right? So now if I go 10 to the power of my answer and hit enter, out comes 2.63. So question number 11, C, is the correct answer. How could we have done this? Well, again, we can use my solve function. I could have done my log, so control and log base 10 of, we'll call it x, is equal to, what do we have in the question? 1.06 minus 0.00674 times, I'm going to substitute the value in of 95, put comma and then x, and solve it, and out comes the value as well. So we could have done that as well. Easy peasy lemon squeezy, he says, hopefully. Question number 12, which one of the following statements could be true when written as part of the results of a statistical investigation? Oh, all right. The correlation coefficient between height and foot length in centimeters was found to be 1.24. Absolutely rubbish. Our R can't be bigger than 1. So there they're trying to trick you. Your R values can go between -1 and 1, certainly not higher. The correlation coefficient between height and arm span in centimeters was found to be that. Again, they're tricking you there because these things there are actually not numerical. And so you can only get a correlation coefficient and do a line of best fit or regression analysis between two numerical values. So that's rubbish as well. So A is rubbish, B is rubbish. The correlation coefficient between blood pressure, low, normal and high, and age was found to be that. And again, you can't find an R value unless both of them are numerical. All right, and so because this here is categorical and that there is categorical, C is also not the answer. So again, this tests your understanding. The correlation coefficient between the height of students of the same age in centimeters and the money they spent on snacks in dollars was found to be R equals 0.22. I'm actually going to say that that's my right answer, but I'm going to check E because they were both numerical and my R value was in range. The correlation coefficient between height, centimeters, and grass yield in tons was found to be minus 0.40, and the coefficient of determination, R squared, was, you cannot have a negative value of R squared. All right, R squared is positive. The whole point of squaring it is to get rid of the minus sign. So there we go, E isn't right. But again, they're all plausible. They all sound plausible, but they're not. Question 13, the association between the amount of protein consumed in grams per day and family income is best displayed using. All right, let's go through this one and see what happens. A scatter plot. Well, at the moment, that seems the most sensible because that is a numerical and that is numerical. A time series plot. No, it's got nothing to do with time. Parallel box plots. That's generally numerical categorical. Back-to-back stem plots. Nope, that's numerical categorical. A two-way frequency table. Nope, I don't know what that's all about. So the best way of displaying that association would be A, which would be your scatter plot. Oh, time series, we just talked about those. The time series plot below shows the daily number of visitors to a historical site over a 2-week period. The time series plot is to be smoothed using 7 median smoothing. I've seen one of these questions recently, funnily enough. The smooth number of visitors on day 4 is closest to 1, 2, 3, 4. So there's day 4. Because we want 7 data items, we're going to do 3 before and 3 after. 1, 2, 3, 1, 2, 3. Now we already know that day 4 is going to be centered here. What I now need to do is find the middle dot going vertically, all right? So this is point 1, it's the lowest, 2, 3, and it would appear that that one is my 4th one. So I would say D for question number 14 is my correct answer because it's 150, all right? So median smoothing, awesome. The table below shows the long-term monthly average heating cost in dollars for a small office. The seasonal index for April is, all right. So the first thing I need to do is I've got to work out the average of all of these values here, right? So to work out the seasonal index for a particular month, and because we're doing April, we're going to find out the average of all those values. So I'm going to do 78 plus 83 plus 73 plus 109. And when you're entering these values in, you should always make sure that what you're entering in is actually going into the calculator. Because if you make a mistake on one of these values, then sadly it all goes horribly, horribly wrong. All right, so fingers crossed that should be all my values. I'm going to divide that by 12 because I know there's 12 months, and that gives me 125. So my monthly average is 125. My seasonal index is given by the actual figure divided by my monthly figure. So 109 divided by 125. So let's do 109 divided by answer. It gives me 0.87. So question number 15B is my correct answer. Question 16, which is the last one in the data section before we move on to financial. Okay, so for this question, it's got a small cafe is open every day of the week except Tuesday. The table below shows the daily seasonal indices for labour cost. Okay, we've got the seasonal indices. Excluding the day the cafe is closed, bit of a trick, the long-term average weekly labour cost is this. So that's the weekly labour cost. The expected daily labour cost on a Wednesday is closest to. So the first thing I'm going to do is 9786 divided by 6. That's going to be my daily cost. So what you see is on my calculator, I have a daily labour cost as $1,631. We then go back to the formula that says our seasonal index is given by the value for the season, or the value, divided by the average. All right, because we're trying to find the value for Wednesday, I'm going to do the seasonal index times the average. And so what you can see here, I've done 1634 times 1.24, which is 2026 and 16 cents. So again, because it wants it closest to E is my correct answer. And what you can see on my calculator is, yes, initially I divided and I was like, oh, that's not right. Make sure you get your formula correct. Moving on to recursion and financial modeling. Hopefully the questions start easier and get more complex. A sequence of numbers is generated by the recurrence relation as shown below. What is the value of P3? Right, firing up my calculator. I know the start value is 2. I know that I'm going to get 3 times my previous answer, and I'm going to subtract 1. So there's my second term. So P0 is 2, P1 is 5, P2 is going to be 14, and P3 is going to be 41. Again, notice that they're trying to trick you there, yes? So P3 actually was the 4th number in the list. So did I write 14? Oh, I did, and then 41. So question 17, D was my correct answer. Question number 18, a truck was purchased for $134,000 using a reducing balance of 1/3. The value of the truck is depreciated by 8.5% each year. It's depreciated by 8.5% each year. Which one of the following recurrence relations could be used to determine the value of the truck after n years? Okay, so because it's years and years and years, we don't have to worry about dividing by 12s or 52s for months or weeks. So we know that V0 has to start with 134,000. All of them do. What we do need to do is work out our depreciation. So 8.5 divided by 100 to turn it to a decimal gives me 0.85. Now, 0.085. What I'm now going to do is take that away from 1, and that is going to give me my multiplier of 0.915. That is basically what you're going to multiply by for a reduction in 8.5%. So let's see what we can automatically reduce here. We're going to get rid of that one, we're going to get rid of that one, and we're going to get rid of that one. All right, so again, 3 answers have gone for that calculation there. Looking at those 2 choices then, let's look at the D. Now, if we look at D, I've circled that, did not mean to circle that. If we look at D, we have a payment being made of $8,576. Well, basically nothing in the question says a payment's being made, and there's nothing in there to help you calculate whether a payment's being made. So D is a bit of a trick. A is in fact the correct answer. Question 19, consider the recurrent relationship shown below. This recurrence relation could be used to determine the value of. Right, now, first things first, whenever I do these questions, I want to work out whether this $2,000 is important and where it's come from. And the way I do that is I'm going to try and work out whether that's my interest being paid. How do we do it? I take the 125,000 and I'm going to times it by 1.013, this interest rate here. So on my calculator, 125,123, and times it by 1.013, hit enter, and out comes 126,625. So that means $1,625 is the interest. Okay, that's going to be important to me because I wanted to check. So taking that answer and subtracting 125 gives me $1,625. Just checking, I don't want to make a silly mistake. Right, here we go. A perpetuity with a payment of $2,000 per quarter. A perpetuity means you're living off the interest. My interest is $1,625. If I take away the $2,000, I'm actually going to spend my principal. That's not going to work. An annuity with withdrawals of $2,000 per quarter. It could be B, all right? It could be B, because annuity basically is a piggy bank that you just take money out of. An annuity investment with additional income payments of $2,000, well, it's not being paid in because of the minus sign. An item depreciating at a flat rate of 1.3%. Now, if it was a flat rate depreciation, we'd work out the interest on the first payment, and that's the interest paid on every single payment. A compound interest investment earning interest at a rate at 1.3% per annum. That is a bit of a trick. Yes, a compound interest investment earning interest at a rate of 1.3% per annum certainly describes it, but it doesn't actually go on to describe the $2,000 withdrawal. Yes, so the recalculation could determine the value of, it's going to be B. 19 is B. That's a bit of a tricky question. Question number 20, Marty, let's zoom out so we can see the whole question. Marty has been depreciating the value of his car each year using flat rate depreciation. It goes down by the same amount every single period. After 3 years of ownership, the value of the car was halved due to an accident. Matty continued the depreciation to depreciate the value of his car by the same amount each year after the accident, which is the following graph. Okay, so in this situation here, what you'll notice is the value of the loan is staying the same, i.e. he's not paying any money off. Well, it says he's doing flat rate depreciation. That can't be the right answer. Here, he is absolutely depreciating, but the value of the car doesn't seem to halve after his accident, all right? This one here cannot be correct because while there seems to be a change in value of the car, because the gradient of the two lines are different, it means he's paying off different amounts. So again, the trick is here, we want the gradient to be the same. Likewise, this is not flat rate because it needs to be a straight line, leaving C as my correct answer. Yours then has a reducing balance loan. Amortization tables are in every single year. 6 lines of the amortization table for Yarzen are shown in below. The interest rate for Yarzen's loan increased after one of these 6 repayments had been made. The first repayment made at the higher interest rate was repayment number. Okay, so to work out the interest rate, you always take the actual interest that was charged and divide it by the balance of the previous loan. So by the looks of things, that's what we've got to do. Look at the interest rate, all right? And work out which one. I don't think it can be 15 either because we don't have anything. So I think you can automatically discount A because it's just not gonna work. All right, here we go then. So 343 divided by, you're gonna say this is gonna take a long time, 34299.5. What have you got there? An interest rate of 0.0, oh, he's done it in highlighter again, 0.01%. Right, so that's written in the wrong way. So let's rub that all together and put it in there. 0.01%. Now what I'm going to do is take this value and divide it by that value. So 403.71 divided by 33642.50. That is going to be 0. Oh, he's done it again. 0.012. Interesting. Our interest again is going to be, so taking the next ones, $396.55 divided by 33046.21 gives me 0.0, so 0.01 again. Let's take the next one. $389.31, and we're going to divide that by 33442.76 gives me 0.1 again, or 0.011. And then let's see what happens here. 381.98 divided by 31832.07 gives me again 0.011. So let's have a look and see what happened there. The first repayment made at the highest interest rate was actually number 17. All right, so again, I misread the question. Whew, that'd have been awkward. Yeah, so 17. So the next set of information is for question 22 and 23. Right, Armand is going to borrow $12,000 to pay for a holiday. He'll be charged interest rate at that per annum compounded monthly. There's my interest rate per annum compounded monthly. That's how much his loan will be repaid with monthly repayments of $500. After 4 months, the total interest that Armand will have to pay is closest to. Right. I'm going to fire up my financial solver. Let's go my menu, finance and financial solver. Right, so it's monthly after 4 months. So 4 is what we're going to do there. My interest rate is 6.12. The principal value was 12,000. It's going to be positive because he's taking a loan. His payments of minus 500. Future value, we don't know at this moment in time. Payments per year are 12. Compound interest per year are 12. And then what we're going to do is we're going to go down here to work out the future value of my loan. Now, the reason I'm going to work out the future value of the loan is that will tell me how much interest I've paid. The reason being is I've paid, I've done it again, I've paid 4 lots of $500, all right? Because that's my repayment over the 4 months, which means I have paid off or should have paid off my loan of $2,000. But I haven't. You notice I've actually not paid off those $2,000. So if I now go, I'm going to copy that and I'm going to go and escape out of it. Plus the value there is going to give me 1,768. That's actually what I paid off. So the difference between the money I gave and that what the loan still stands at or what I've paid off is my interest. If I do 2,000 and I'm going to subtract from that my answer, I'm going to get $231. So question 22 is A, which is the correct answer. After 8 repayments, Armand decides to increase the value of his monthly repayments. He will make a number of monthly repayments of $850 and then one final repayment that will have a smaller value. This final repayment has a value that's close to. So this is a change of conditions. We go back into my financial solver and we've luckily got this here. So after 8 repayments, we've got 8 repayments. He's still sticking with the $500. So what we're going to do is work out how much he owes. So he still owes $8,426.30. Now again, I'm not going to round it on my calculator because I can just copy it and put it over. That becomes my new principal value because when we do a change of conditions, we have new principal values. All right, because this is a change of conditions, what we're now going to do is we're going to say, right, okay, we are going to do, I'm going to copy that and that's going to become my new principal value. So there's my new principal value, but I'm going to take away the minus sign because it's almost like he's taking out a new loan. He's paying off $850. He's paying off his loan, so his future value is going to be 0, which means we need to try and find the number of payments he's going to make to clear his loan. And what we've got there is 10.1 payments. All right, so 10.1 payments. Well, we can't do 10.1 payments. So what I'm actually going to do is I'm going to say, well, all right, so let's see how much he owes after 10 payments. So after 10 payments, he still owes an additional $168. That's what the minus sign means, right? So that minus sign tells me he still owes $168, but he has to pay the extra 28 cents. And what you notice with question 23, it was more a semantics question. They were trying to trick you with the wording. If he paid just $168, he'd still owe the bank 28 cents. So actually his final repayment is closest to $169. Tricky, tricky, tricky. Question number 24. Robin has a current balance of that in her superannuation account. Her deposit's $350 in account every fortnight. Cool, lots of language here. So there's my principal value. Deposits every fortnight. The account earns interest at 2.5% per annum, compounding fortnightly. Okay. Robin will stop work after 15 years and will no longer receive deposits from her employer. The balance of a superannuation account at this time will be invested in an annuity, so we've got another change of conditions. They'll pay interest at a rate of 3.6% per annum, but this time compounding monthly. After 234 monthly payments, there will be no money left in Robin's annuity. The value of Robin's monthly payment will be closest to. All right, so first things first, let's deal with the first thing. It's basically up until that 15 years. So let's go and say Robin has a current balance of, so she's 15 years, compounding fortnightly. So we need to times that by 26 because there's 26 fortnights in a year. So that's first thing, that's the trick. The interest rate was 2.5%. Her principal value was 347,283.45. All right, Robin's has it in her superannuation account. Okay, they're going to be minus. Yes, I'm going to make it minus because it's like money being paid in. We're giving in a superannuation account. Robin's employer deposits 350, so minus 350. Payments per year are 26. And if we go down here, the compound periods per year are 26 as well, because it's every fortnight. So if I now go back to the future value of her investment, that's how much she's going to have after 15 years. 670,724.87. So now we're going to change conditions, yeah? So basically now her superannuation account at this time will be invested in annuity. So I'm going to copy that value back to my principal value. I'm going to make it negative because that was effectively a minus we've given it. And I am going to say, rightio, the balance of superannuation will be interest rate of 3.6%. Compounding monthly, so we're going to make that 12, and that's going to automatically default to 12. After 234 payments, so we've given the number of payments, the money will all be gone, which means our final value will be 0. So they've given me all the information I need. Fingers crossed, if I now hit payment, it means she is going to receive from her superannuation $393.31. So it's closest to A, which is my correct answer. Ladies and gentlemen, that is the end of this video. Thank you very much for watching. 2019 Northern Hemisphere Solutions complete, at least for the core module. More of the other modules and the multiple choice questions are coming soon. Thanks very much for watching. Hopefully it's useful. If you can, leave a comment below if you are on YouTube. Otherwise, head over to Maths Guru, where there's so much more. You guys take care and give me a shout out to your mates if you can, that these videos are there. Take care, guys. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.